Green manufacturing. It may sound like a contradiction in terms, but in this age of global warming, overflowing landfills, and dwindling water supplies, there is a growing worldwide movement to minimize manufacturing's impact on the environment. Xerox is a leader in this area with a pioneering electronic equipment take-back program that began in the early 1990s.
In the early 1990s, Xerox had a little bit of a problem. A lot of our products that we lease were coming back off of lease, and they were filling up warehouses. And we said, gee, what are we going to do with these? You know, we're spending money to store them. We don't want to throw them out. We don't want to put them into the waste stream because there's a significant amount. So somebody got the idea, well, you know, there's probably still some reusable portions of those machines. Let's start reusing what we can. And so that's sort of what's triggered what we called our waste-free initiative, to design waste-free products to be manufactured in waste-free facilities to enable waste-free customer sites. So to be able to do that cost-effectively, we actually incorporated into the design of our products. So designing the products so that they're easily disassembled, so that there's a minimal number of materials. For example, at one point we had 500 different plastics in a machine, reducing that to 50 different types, and then actually marking them so that when we get them back, we can reuse them, or if they're not reusable, then we can look at what's marked on the part and put it into the right recycle bin. Not all of our products are designed for remanufacturing, so that's important to know. But for the ones that we do, all of our internally designed products are designed for remanufacturing. When we get them back, typically well over 90% of the parts and materials are remanufactured or recycled. And so, for example, I think it's in 2005, I have a little statistic here, 38,000 metric tons of equipment was returned to Xerox. And of those metric tons, only 2% of the material was actually made it into the waste stream. The remainder were remanufactured or got into a recycle stream. The energy that was saved through a combination of designing our products for energy efficiency, remanufacturing parts, and recycling saved, and let me look at, I want to get this correct, 700,000 metric tons of carbon dioxide. So, and carbon dioxide is what's been linked to global warming. So that prevented a lot of carbon dioxide. But what that equates to, which is kind of interesting, is basically taking 150,000 passenger cars off the road for a year. And it also is the equivalent of 80 million gallons of gasoline. So just to put it in perspective. But it also is good for the business, because Xerox saves several $100 million a year in this. So it's an initiative that truly is both good for the environment as well as good for the bottom line. So there's sort of two aspects of disposition. One is so that we can look at a part and say, this is a part that can be reused or remanufactured, or it can't be, it needs to get into a recycle stream. But even those parts that can be reused, eventually they wear out, they can't continue to be reused, you know, indefinitely. So there's a recycle mark on there to tell us how we recycle them. That's the what bin you put them in. So there's those two dimensions of part marking that help us both identify what can be reused, and then when they're no longer reusable, how that we should recycle them. What we essentially do is we'll design a product with in mind that in the future we'll have new features and functions to add. So there's commonality in parts, there's also commonality in size. So an example of that would be a frame. So a machine frame would be designed for the platform so that future products, if we add certain features and functions, we can just reuse that particular frame, for example. So there's the element of being able to use similar parts, you know, on the platform. So a platform may give rise to, say, a dozen products. Okay, so in some instances it'll be a platform that has products that are 20 pages per minute. And then there's a product that prints, say, 40 pages per minute, and a product that prints 60 pages per minute. They're all off the same platform, and they use a lot of the common parts so that when we get them back, we don't have to have all of the cost and logistics around separating the parts into the 3 different products, because that part can go into any one of those products because it's part of the same platform. The other thing that we do is we can bring back a product, for example, that is a 20 page per minute printer and say we have more of a demand for a 40, we can upgrade it because it's part of that platform. So it gives us a lot of flexibility, which enables more remanufacturing. The products that that aren't remanufacturable, either because there's not a demand for them or because of the wear and tear was just too significant, we'll tear those down and recover the parts that we can reuse and get those back into the part inventory. And then for those that we can't actually reuse the parts, we get those into the recycle stream. And then we have testing called signature analysis, which tells us how much life is left in a part as to whether it can be reused. A frame. If you think about it, how much wear and tear does a frame take over its lifetime? Some of the ones that get a little bit more sensitive are those that have moving parts, for example. But even motors and wire harnesses are things parts that can be reused. And, based on the signatures that we test, which include things like vibration and heat dissipation, those kinds of tests will tell us what that life that is left in that particular part. But one of the impediments that we had over the years is the perception that these sorts of products that are containing reused parts may have inferior performance. The Xerox has the same total satisfaction guarantee, regardless of whether it's 100% virgin new or whether it's remanufactured. So basically that says we know they're going to perform the same way. But because of the perception, we had a challenge, particularly with government contracts. They would put out requests for proposals saying, bid products that are only 100% virgin new. So I went out and met with some of the procurement people in various states and local governments to ask them why they were doing that. And they said basically because they felt that Xerox had a good quality product, but they were concerned that if they didn't put those requirements in a request for proposal, that they would have others that would be bidding inferior products. So we said, okay, well, how can we help you be able to open it up so you can actually meet your own environmental goals, but not open it up to having inferior quality products. So we actually got working on an international standard, an ISO standard called 24700, which is basically around the world various corporations and standards bodies working together to define what are the quality parameters for products that contain reused parts, so that we look at what is the quality and performance as opposed to what's inside the box to address the customer's concern or perception that there might be inferior quality. We do have some customers that say they do not want remanufactured products. So we do need to be able to track that we're delivering to customers' requirements. We have some that ask for remanufactured products too. So we do have the ability to track them, but they basically are managed through the same inventory process. We don't have as much of the concern anymore from customers about machines themselves that are remanufactured or have reused parts in them. I think it's gotten more positive from that standpoint. We actually have some customers that really like to do that because it's consistent with their environmental programs and their environmental commitments. We also have established a goal we call our Energy Challenge 2012 to reduce our overall greenhouse gas emissions by an absolute 10% from over base year 2002 and achieve it by 2012. And that 10% absolute means if the company grows, we still have to meet that 10% plus whatever the growth is that we've incorporated. So we translated that into over 30% efficiency improvement to be able to achieve that 10% absolute reduction. So we've been working on that and through design, technology, through even just easy things like shutting down lights, having sensors, making sure that people are powering down their computers, those kinds of things. And we think that we're going to achieve that goal actually way ahead of 2012. And so we'll be establishing the next level of aggressive goal.